Right, so chemistry 5.3, metals and their extractions. Okay, these are the past paper questions for that topic. The first question here is quite a nice question because they have given you the reactivity series. Some questions will rely on you having a little bit of a knowledge of the order of the reactivity series, but this is a nice question to get started because they have given you the order. Predict, giving a reason whether the following pairs of substances react and give any expected observations. So straight away it says iron and copper sulfate. I'm looking at my reactivity series and I can see that iron is higher up than copper. So iron is more reactive, will displace copper. Iron sulfate plus copper, that's what it will become. Observations, when it starts, it is blue because copper sulfate is blue. It'll turn to green because iron sulfate is green. Moving on to the second one then, magnesium and dilute hydrochloric acid. This is kind of related back to the acids, bases and alkalis topic. Magnesium and hydrochloric acid will react to form magnesium chloride. You would observe fizzing and a bubbling of hydrogen gas being given off. Then finally, aluminium oxide plus carbon. If you go look at the table, even though carbon isn't a metal, it does sometimes appear in the reactivity series, so does hydrogen. And as you can see, carbon is below aluminium, so nothing would happen there because aluminium is more reactive. Moving on then to question number 2. Question number 2 is an electrode question or electrolysis question. Straight away, I've written down the side. As soon as I see anything about electrolysis, I write the panic anagram. Positive anode, negative is cathode. So I know which way, if they don't give you it, because sometimes they do, sometimes they don't, I know that the cathode is negative and the anode is positive. For electricity to flow, the lead bromide must be molten. Give reasons for your answer, okay? This is relating a little bit back to just metals on their own, and then compounds that, then ionic compounds. Ion need to be free. If the ions aren't free, then they won't be able to move. So if they can't move, they won't be able to conduct electricity. So when they're molten or dissolved, that means they can conduct electricity because the ions are free to move, okay? Balance the electro equation which takes place at the anode. So anode is positive, is going to attract something that is negative, in this case bromine, and as you can see you've got end up with 2Br as a compound, so you've got to have two electrons and then 2 of the negative ion. State in terms of electrons what happens to the lead ions at the cathode. The cathode, what's going to be happening is the lead is going to be giving up its electrons and becoming a positive ion. Positive is loss of electrons, to donate them to the non-metal, which will become a negative because negative is a gain of electrons. Describe what you would observe at the cathode. I would observe lead being produced, okay? So from that molten lead bromide, I would see lead forming on the cathode, and it's kind of like a silvery metal that would be forming. Electrolysis is allowed to continue for some time before the apparatus is cooled to room temperature. The bulb remains lit. Explain this observation. The largest idea behind this would be that a certain amount of residue remains on the cathode and the anode, which allows for a complete circuit to still form. So some of it hasn't quite reacted, or you haven't been able to take it off, and it's ended up being still on the cathode and anode, so the electrical circuit is still technically whole. Moving on then to question 3, again another electrolysis question. They're quite common questions, and as you can see I've written it again, that panic anagram just in case, but in this question you can see they've actually given you the positive and the negative, but you never know, so write it down anyway. Aluminium is obtained by electrolysis of molten, again alumina, which means it's been turned into likely a liquid, so the ions again are free to move. The electron equation below shows the products that are formed, so it's 2 electrode equations. They balance together then to make what is formed. Choose from the equations above an ion. So you're choosing an ion, which means it's got to have a positive or a negative charge. It is essentially an atom which has lost or gained an electron. So you could have picked either the oxygen 2 negative or the aluminium 3 plus. An atom, so something that is on its own, that would be aluminium, and then a molecule is just 2 atoms bonded together. So in this case it would be the oxygen or the O2. At which electrode is aluminium formed? Give a reason. As you can see, it's for 2 marks, so give a reason for your answer. Opposites attract, so the aluminium is going to form at the negative cathode because it's a positive ion. It's going to be attracted to the attracted to the other charge. Use the information in the diagram above to give the chemical name and formula of aluminium, or the aluminium that's used, okay? So you can see that you're in the reaction, you're using aluminium and oxide, so it's got to be aluminium oxide, which was your starting point, okay? So there's 1 mark for that. The second mark then is for working out the formula, which you can see on the side. I've turned to the back of my table of ions. And aluminium's got 3+ charge, whereas oxygen's got 2- charge, and we're trying to get them equal on both sides to 0. So when you start out, you've got 3+ and 2-, which doesn't equal 0. So if you add another 3+, you've still not got it right, but if you add an extra 2 2-, then you've got it equal. So that's the formula there. Al2O3. State 1 environmental problem associated with the electrolysis of molten aluminium. Greenhouse gases are emitted when fossil fuels are used to make the electricity. Okay, that's the biggest problem with electrolysis. Give a different property. Can you see I've highlighted a different property of aluminium and one use that relies on this property. Aluminium is known for its being soft and malleable, which is often used in foil and tin cans. Moving on then to question number 4, again, is a bit of a harder question then because they haven't given you the reactivity series. Instead, they've given you reactions to see whether anything happened, if any displacement took place. In the experiment, different metals are placed in solutions of 4 different nitrates. A tick in the table below indicates where the reaction took place, so whether a displacement reaction took place, and a cross indicates that no reaction took place. List the metals in order of reactivity, giving the most reactive at the top and the least reactive at the bottom. As you can see, I've highlighted that because you never know. They might say the other way around, so you've got to make sure that you're reading the question a couple of times before you answer it. So before I again answered it, I've written which one's got the most reactions, so which one's got the most ticks, which is obviously going to be the most reactive. Then moving along, so I can see that magnesium's got the most reactions, silver's got the least reactions, and then copper had 2 reactions, and iron had 2 reactions and copper had 1 reaction. So straight away I can see there and I can write them the most reactive based on how many reactions they had. Balance the equation for the reaction that takes place between iron and silver nitrate. This is kind of a chemistry 1 topic, but you've got to remember it for chemistry 2. They will ask you to balance equations and it's a nice way to pick up some easy marks. As you can see, I've written how many of each atom I've got, how many of each element I've got below, and I've ticked and crossed them to see whether they balance. Then I've worked out via trial and error, so sometimes you've got trial and error, use the space below to work out a way so that they all balance. The second part of this question then, the following table shows the results between the zinc metal when placed in 4 different solutions. So when did zinc react? When did zinc not react? It's only going to react if zinc is the more reactive metal in the reactivity series. Complete the table below with expected results when iron, copper, magnesium, and silver are placed in a zinc nitrate solution. So which one is going to be able to displace that zinc from that nitrate? And realistically, the only one which is further above magnesium on the zinc on the reactivity series is magnesium. So that's the only place you would expect to see a reaction. Part B. An iron is placed in a copper nitrate solution as shown below. Okay, this question comes up quite a lot. Describe what is observed. So what will be happening? Iron is more reactive than copper. So the iron is going to replace and displace the copper from the nitrate. So you're going to end up with iron nitrate and copper on its own. So as that happens, the copper will be forming on the iron nail. So the iron will be coming off the nail and copper will be forming on it. So you'll end up seeing like an orangey brown kind of like rust appear on the iron nail, and then the blue solution is going to turn green as it's no longer copper nitrate and it's turning into iron nitrate. Give the word equation for the reaction. It's a simple displacement equation. So you start with copper nitrate plus iron, you go to iron nitrate plus copper. So a really simple then displacement reaction. The more reactive metal will displace the less reactive metal. Number 5 then is a blast furnace question. You need to know all the different parts of the blast furnace, what goes in, what comes out, and the reasons. Iron is extracted in the blast furnace. Iron ore, limestone, coke, and hot air are the raw materials, so the starting materials, what goes in at the start. Give reasons for adding each of the following to the blast furnace. Coke, which is just a version of carbon, will burn with the hot air to produce heat. So that's why we add coke. Limestone contains calcium carbonate, which will remove any acidic impurities in the process of making iron. So again, another balancing equation. I've written down the bottom. Purple pen is what we started with in terms of the elements, and then the pink pen is where I've done trial and error. Okay, the first thing I actually tried to do, I said I tried to put a 2 in front of the CO. It didn't work because you didn't end up with it right on the other side. So I then added a 3. So again, it is trial and error. Make a mess. It will come up. It's a good way to pick up marks. Give the chemical name of the substance which is reduced in the furnace. So what has essentially lost oxygen and gained, has lost oxygen and has gained electrons. So in this case, it would be the iron oxide, because that's what's losing the oxygen. The graph below shows the tensile strength of iron alloys change with the percentage of carbon present. So as you essentially have more carbon, the tensile strength, which means how much you can hold, changes. Describe the tensile strength changes as a percentage of carbon present increases. So this is a little bit of a funny one. This is a describing graph question. It's worth 2 marks, so don't throw away these 2 marks. So I just describe exactly what I see going from 0 all the way to the 4. So between 0 and 0.8% of carbon, the tensile strength increases, so it's going up. Don't write going up, it's increasing. However, after 0.8, as the percentage of carbon increases, the tensile strength starts to decrease. And as you can see, by the time you get to 4% of carbon present, the tensile strength is at its lowest possible value. The table below shows the percentage of carbon present in some iron alloys. So different alloys, how much percentage of carbon is present. Use the information on the table and the graph to name the alloy which has the lowest tensile strength, okay? I know it's only worth 1 mark, but 1 mark can be the difference between whatever grade you're aiming for. So you need to be really careful. So I have gone back to the graph and worked out what the tensile strength for each of these percentages, and I've written it next to it in purple, and then straight away I know that it's cast iron because that's got the lowest tensile strength. State what is meant by an alloy. Again, this is just a really simple remember question. A metal is made by combining 2 or more metal elements. Okay, so when a metal alloy is when you've got 2 or more different elements added together to make something. And then the final question on this paper was a 6 mark question. So again, you can see an awful lot of work has gone into it before I start answering the 6 mark questions. Okay, so I've worked out what the command words are: relate, describe, use. We've got to say what you see, talk about their uses, and relate them to their properties. Core knowledge. So what do I already know about metals? And from there, I'm most probably getting my keywords. And then sentence starts. How am I going to start this long answer question? Don't just rush into it. Take the time. Okay. Describe the properties of metals and relate these properties to the uses of 2 metals of your choice, okay? So that's the hard part, because you've got to think of 2 different metals. So the first paragraph then, again, lay it out nice and neat. Metals are very strong with high melting points. They have the ability to conduct electricity due to the delocalized electrons and the positive ions. They are malleable as the layers can slide over each other. So that's what I talked about. I gave a brief overview of what a metal is. Moving on then, copper is used in electrical wiring as it is a good conductor of electricity. So that's one use of metals which relates to a property. The second one then I used was steel, which is a metal alloy containing mostly iron. Is used in car bodies as it's strong and malleable, so it can be bent into shape. Again, in the pink pen, I've gone and talked about where you get the marks. So 1 mark for describing what a metal is. 1 mark then for saying a use of a metal. In this case, I used copper, and then a 2nd mark for saying what its property is, and then the same thing repeating it. So there's 5 marks there. Then 1 mark you can see down the bottom in pink is for the spag and the organisation. As you can see, I've tried to organise it in paragraphs so it's easier to read, so you guys can go back and check.